Hello and welcome to Saurav's classes. Today we are going to discuss the mathematical statistics paper of JAM 2022. Here's the first question. There is a function defined in the real domain as limit of h tending to 0 of this expression when x is not equal to 0 and is 0 when x is equal to 0. Then which of the following statements is not true? So as you can see that fx is nothing but, by definition, this is the derivative of x sine of 1 by x when x is not equal to 0, and this is 0 when x is equal to 0. So the derivative of x sine 1 by x will be sine of 1 by x plus x into cos of 1 by x into 1 by x square. So which gives us sine of 1 by x plus 1 by x into cos of 1 by x. So now we look at the options. The first one is f of 2 by pi. Now that means x is equal to 2 by pi and 1 over x is pi by 2. So if you put x equal to pi by 2, 1 by x equal pi by 2 in this expression, you get sine of pi by 2, which is 1 plus pi by 2 into cos of pi by 2, which is 0. So that means this is equal to 1, which is correct. F of 1 by pi. Now 1 by pi will mean x equals 1 by pi. So 1 by x will be equal to pi. So the expression will become sine pi, which is 0, plus pi into cos pi, which is negative 1. So that means the expression for this will be equal to negative pi. So the second one is incorrect. So this is not true. So this is your answer. Now you can work out the rest. F of minus 2 by pi would be sine of minus pi by 2, that is minus 1, and so this would be minus 1 plus minus pi by 2 into cos of minus pi by 2, which is 0. So this is minus 1, this is again correct, and fx is not continuous at x equal to 0. Now at x equal to 0, the value of fx is 0, and if I take the limit of the expression of fx tending towards 0, this would be sine of 1 by 0 plus 1 by 0 cos of 1 by 0. So sine of 1 by 0 will be a number between minus 1 to plus 1. Similarly, this will be a number between minus 1 to plus 1, and this expression will tend towards infinity. So that means the expression of fx as x tends to 0 will not be equal to 0. So therefore it is not continuous at x equal to 0 is correct. We move to the next question. Here the function fx is given by the determinant of the given matrix. So first of all we have to find the determinant of this matrix. So that means f of x will be 1 plus x multiplied by 1 plus x whole square minus 81 minus 9 into 9 into 1 plus x minus 81 plus 9 into 81 minus 9 into 1 plus x. So simplifying this, we get 1 plus x whole cube minus 81 into 1 plus x minus 81 into 1 plus x plus 729 plus 729 minus 81 into 1 plus x. So which is 1 plus x whole cube minus 243 into 1 plus x plus 1458. So this is the expression for f of x. Now the question is, what is the maximum value of f in the interval of 9 to 10? Now as you can see that the expression for fx is this. So f dash x will be 3 into 1 plus x square minus 243. So for f dash of 9 will be 3 into 10 square, that is 300 minus 243, which is 57. So this is positive. So f dash is positive at the point x equal to 9, which means fx is an increasing function at x equal to 9. Similarly, f dash of 10 will be 3 into 121 minus 243, which will be 363 minus 243, which is 120. So this is also positive. That means fx is definitely increasing in this interval. So that means the value of f of 10 will be greater than f of 9. So the greatest or the maximum value of f in this interval will be at f10. And what would be the value of f10? So from here, f10 will be 10 plus 1, 11 cube minus 243 times 11 plus 1458. So you calculate this, you get 1458 minus 11 into 243 minus 121, that's 122. So that gives you 1458 minus 1342, which is 116. So your answer is 116. We move to the next question, which says A and B are two events such that both probabilities lie between 0 and -1. That means neither of the events are improbable, or neither of the events are certain. So they will have a distinct finite possibility or probability which lies between 0 and 1. Now which of the following statement is not true? So the first one, if P of probability of A given B is greater than probability of A, that means probability of A given B is probability of A intersection B by probability of B, and this is greater than probability of A. So probability of A intersection B will be greater than probability of A into probability of B. So therefore probability of B given A will be probability of A intersection B by probability of A. So probability of A intersection B by probability of A will be greater than probability of B. So this one is correct. We have to find the one that is not correct. If probability of A union B is 1, then A and B cannot be independent. So probability of A union B is probability of A plus probability of B minus probability of A intersection B. Now let us assume that A and B are independent. So if A and B are independent, then probability of A intersection B will be equal to probability of A into probability of B. So therefore you get probability of A union B, which is 1. So you get probability of A plus probability of B minus probability of A into probability of B minus 1 equal to 0. So that means probability of A minus 1 into probability of A minus 1 plus or rather minus probability of A minus probability of B into probability of A minus 1. So you club the first one and the last one and the other two. So this is equal to 0. That means probability of A minus 1 into 1 minus probability of B is equal to 0. So that means either probability of A is 1 or probability of B is 1, which according to the given condition is not possible. So therefore the assumption that A and B are independent is wrong. So A and B cannot be independent. So that this is also true. Now we come to the third one. Probability of A given B is greater than probability of A, which we have already done here. Then probability of A complement given B complement. A complement given B complement means third one is probability of A complement given B, that is probability of A complement intersection B by probability of B. So probability of A complement intersection B means probability of B minus probability of A intersection B divided by probability of B. So this would be 1 minus probability of A given B. So probability of A given B is greater than probability of A. That means if this is greater than probability of A, then this expression will be less than probability of this will be less than 1 minus probability of A, which means this is less than probability of A complement. So that means this expression is correct. The last one says probability of A complement given B complement should be less than probability of A complement. Now this one is probability of A complement intersection B complement by probability of B complement, which is probability of A complement intersection B complement means 1 minus probability of A union B by probability of B complement. Now from here you cannot say anything whether this will be less than probability of A complement or not. So that means this is not true. So this is your answer. Okay, the next one says X is a random variable having binomial distribution with parameters of n greater than 1 and p lying between 0 and 1. Then what is the expectation of 1 by 1 plus x? So expectation of 1 by 1 plus x will be equal to the sum of 1 by 1 plus x into the uh, probability of 1 by 1 plus x. So this is the expression, and this this can be written as summation of x equal to 0 to n 1 by 1 plus x into ncx into p to the power x into 1 minus p to the power n minus x. So this is the summation of this. So now we know that ncx by 1 plus x into p to the power x can be written as factorial n by factorial x into x plus 1 into n minus x factorial into p to the power x. So this can be written as, now I multiply the numerator and denominator by n plus 1. Multiply the numerator denominator by n plus 1. So then it becomes and also with p. I multiply the numerator denominator with p. So then I can write this as n plus 1 factorial by x plus 1 factorial. This part will give you x plus 1 factorial into n minus k factorial into n plus 1 into p into p to the power x plus 1. So that means this can be written as 1 by p into n plus 1 and then n plus 1 c x plus 1 and then p to the power x plus 1. So that means this becomes my alternate expression for this part, for the first part. ncx, this part can be written like this. So that means I replace this one out there. So expectation of 1 by 1 plus x becomes equal to 1 by p into n plus 1. Now since the summation is over x, I can bring p and n plus 1 outside the summation. They are constants, into summation of x equal to 0 to n into n plus 1 c x plus 1 into p to the power x plus 1 into 1 minus p to the power n minus x. So this becomes the expression for expectation of 1 by 1 plus x. So therefore, now we know that um, 1 is equal to p plus 1 minus p, right, to the power n plus 1, which is equal to p to the power n plus 1 plus nc1 n plus 1 c1, sorry, into p to the power n into 1 minus p, and so on up to 1 minus p to the power n plus 1. So now you look at this expression out here, which is the sum of all the terms starting from x equal to 0. That means it will start from n plus 1 c1 into uh, p to the power 1 into uh, 1 minus p to the power uh, n minus 1, right, or rather 1 minus p to the power n. So actually we could have written it the other way around, then it matches with the expression. So 1 minus p to the power 1 minus p plus p to the power x plus 1 will be given as 1 minus p to the power 1 minus p to the power n plus 1 will be given as 1 minus p to the power n plus 1 plus n plus 1 c1 into 1 minus p to the power n into p, and so on up to p to the power n plus 1. Now if you compare these two expressions, it starts with n plus 1 c1 into p to the power 1 into 1 minus p to the power n minus 1. So um, so it starts off with this expression up to this expression. So that means what is this sum will be equal to, so the sum of x equal to 0 to n plus 1 c x plus 1 p to the power x plus 1 into 1 minus p to the power n minus x becomes 1 minus p to the power n plus 1. So this whole sum becomes equal to this. So that means the expectation of 1 by 1 plus x will be 1 minus p to the power n plus 1 by p into n plus 1. Now let's look at the options. So the first option is the correct one. We move to the next question, where we are asked to find the limit of a sum. So this is limit n tending to infinity 6 by n plus 2, and then you expand each of the terms. So you get 2 square plus 2 into 1 by n plus 1 by n square plus 2 square plus 2 into 2 by n plus 2 by n whole square, and so on up to the last term, which is the n minus 1th term. So the number of terms will be 1 to n minus 1. So up to n minus 1 terms. So this will give you limit n tending to infinity 6 by n plus 2 into, now 2 square plus 2 square, and like that you will have n minus 1 terms. So that means 2 square into n minus 1, and then you will have 2 into 2 into 1 by n, that means 4 by n into 4 by n into 1 by into 1 plus 4, 1 plus 2 square plus 3 square up to n minus 1. No, I'm sorry, this would not square, this would be linear. So 4 by n into 1 plus 2 plus 3 up to n minus 1, and then you have 1 by n square plus 2 by n whole square, that means 2 square by n square up to n minus 1 square by n square. So which is limit n tending to infinity 6 by n plus 2 into 2 square into, or we can write 2 square as 4 into n minus 1, 4 into n minus 1 plus 4 by n into, this is the sum of the first n minus 1 positive integers, that means n minus 1 into n by 2 plus, this is the sum of the squares. If you take 1 by n square common, this is the sum of the squares of 1 plus 2 square plus 3 square up to n minus 1 square. The sum of the squares of the first n minus 1 integers, which is n minus 1 into n into 2 into n minus 1 plus 1 by 6. So simplify this, limit n tending to infinity 6 by n plus 2 into 4n minus 4, or you can cancel this out, so this becomes 2 and 4, 2. So 4 plus 2, that means 6 into n minus 1, and here also I can cancel out one of the n's, and I get plus 1 by 6n into n minus 1 into 2. So n minus 1 into 2n minus 2 plus 1, so 2n minus 2 plus 1, so 2n minus 1. So this is your expression, and then you simplify this further, so you get limit of n tending to infinity 6 by n plus 2 into 6, you can take n minus 1 common, into 6 plus 2n minus 1 by 6n, which is limit n tending to infinity 6 by n plus 2 into n minus 1 into 36n plus 2n, that is 38n minus 1 by 6n. So this becomes limit n tending to infinity. Then you have 6 and 6 will cancel out. Then you have n minus 1 into 38 n minus 1 by n into n plus 2. So this can be written as limit n tending to infinity. You take this n minus 1 by n, that becomes 1 minus 1 by n, and then you divide both numerator and denominator by n, so this becomes 38 minus 1 by n upon 1 plus 2 by n. So now if you put n tending to infinity, that means 1 by n tends to 0. This becomes 1 into 38 by 1, which is 38. So the answer will be option A, 38.